Case number 24. We are to determine whether the square of the sum of tangent x and cotangent x will result to the product of secant squared x and cosecant squared x. We are to verify this given identity by first moving or transforming or manipulating the left-hand side of the equation and looking for processes that will allow us to reach the right-hand side. Here, we are going to use first the transformation of tangent and cotangent x in terms of the combination of sine and cosine without manipulating first the exponent. Then, we might be using a Pythagorean identity on the process. So here is the first step. Again, we will just simply come up again with the same expression of exponentiation, and we are going to transform tangent x and cotangent x in terms of sine and cosine. Tangent x is the identity equivalent to the ratio of sine x by cosine x. This is the tangent x. So plus our cotangent x, on the other hand, is its reciprocal, the cosine x over sine x. Okay, so from this, we are going to manipulate this without moving first or without applying the exponentiation, and hopefully we could arrive with the left-hand side, or the right-hand side rather. From here, let's try to combine the rational expressions inside the exponentiation, and we could do that by looking for LCD. We have here the denominator of cosine x and sine x here. So we are to add rational expressions. So again, the LCD here is the product of the denominators. You have here cosine x times sine x. Just like 1/2 plus 1/3, your LCD is 6. That's 2 times 3. So similar here, we're just multiplying cosine x and sine x. By the way, what would be our hint in solving for this case? Take note that our end result is a product of secant squared x and cosecant squared x. So our goal in mind is to come up with an expression that would result to a product. We have here the exponentiation of the sum. If you're going to apply the exponentiation, you will have a series of terms that is added to one another. So it's far from the product. So hence, we will just combine first the terms inside the grouping symbol before applying the exponentiation later. So if you're going to come up with equivalent fractions, you divide this LCD by each of the denominator. Cosine x times sine x divided by this. So you'll be removing that. You will have sine x left to be multiplied to your numerator. So sine x times sine x, you'll have the square of sine x. Take note that if you're going to simplify this, you will just return to your original form as you're going to remove one of the sine x here. Similar thing on the other side, divide this by sine x. So you will be having cosine x to be multiplied to the same cosine x. So you will have here the square of cosine x. Take note of the operation of addition, you will have it like this. Next thing to do here is to look closely at our numerator. This numerator alone, okay, is equal to 1. This is actually part of the Pythagorean identity. We'll have sine, or the square of sine x, plus the square of cosine x, the same angle x, is equal to 1. There are 3 Pythagorean identities, but this is the simpler, and we know that to be equal to 1. What happens here is you will have now 1 over your entire denominator, cosine squared x, cosine x and sine x. Okay, this is still under the exponentiation. Now that we have established only singular term here, we can now apply the exponentiation. And by loss of exponents, you're gonna give it to all the terms inside the grouping symbol. Hence, you will have 1 squared, or simply 1, over cosine squared x, and the square of sine x. This is after you have applied your exponentiation. Of course, this is 1 squared, but automatically it's just equal to 1. The next part here is, since we already have one term here, and take note that your denominator is a product of two expressions or two identities, let's try to separate them into two different identities or two different rational expressions. You have 1 over the cosine squared x times 1 over sine squared x. Notice that we can just simply separate them with ease, and our numerators are both 1 because under multiplication 1 is just 1 times 1, and we simply multiplied it like this. So we're just separating them. Why we separate them? Because our goal is to come up with the product of two different identities, and 1 over cosine squared x is secant squared x, and 1 over sine squared x is cosecant squared x. This is the target, this is the expression, these are the identities on the right hand side of our equation, and hence we have now verified this given identity. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.